Hi, this is a video to kind of summarize today's class from, I guess, September 21st and September 22nd. Just be mindful that I'm talking about a day's lesson for those 2 days because we are in block schedule. So let me go over what we discussed those 2 days or within those days. So we went ahead and talked about how to make your notes. I do not know if you're required to do Cornell notes for your other classes, but for me, I want you guys to take readable notes, organized notes, notes that are easy to reference. So use symbols on equations so your eyes go straight to it. For example, you could put a star on your equation. That way, you could definitely go back and quickly reference it. Include date and the unit. Make sure you include your date and unit. That way, you can stay organized. And let me go ahead and move on to a little bit more of what we talked about today. Part of your notes, I asked you guys to take this question or actually write it down in your notebook. So the question is, how can you measure and represent the probability of a real world event? We talked about this very often, and I explained to you guys that probability is measured from 0 all the way to 1. 0 is a representation of 0%, 1 represents 100%. And we already know what the limits or probability of 0 represent. Very similarly, we know that probability of 1, it represents the opposite of 0, which means it will happen for 1, and for 0, it will not happen. And in between these values, you have fractions of probability. You have an even chance, unlikely chance. You also have very likely. And we use an equation. So to answer this, you use an equation that gives you values from 0 to 1. And let me go ahead and move on. So in class, I did show a video. It's not necessary for you guys to watch, but it was sort of helping students to understand that tree diagrams organize, uh, I guess, combinations of events or events in general to kind of give you a total outcome of your sample space or for the equation. But I guess we kind of really focus on this learning target, which was you can create a tree diagram to organize outcomes and to help you find the total outcomes of a single event. Now, we did do more than just that. We talked more about making combinations because based off combinations, you could find probability, and we just didn't want to complicate it for you guys. So the first example we went over, it was Jose's parents took him to a clothing store and told him he could get one polo shirt and one pair of pants. The shirts and pants he can choose from are listed below. Draw a tree diagram that correctly shows of all Jose's choices of combinations. Go ahead and read it to yourself again. All right, after you're done reading this again to yourself, definitely ask yourself, what is this question or statement asking you to do or find? All right, I hope you were able to identify that it was telling to you to do a tree diagram to correctly show the combinations that Jose can pick from. So to do this tree diagram, we start off just like any tree. We start from the stem, and we're going to make branches. So we read from left to right. We read from left to right. So using that idea, we're going to read the table from left to right. We're going to read the table from left to right. Okay, so we're going to start off with the shirts. Based off the shirts, we have red polo and black polo. So there's two options here. That means you should have two branches. One of the branches should be a red polo. I'm going to use RP for red polo. The other option is black polo. I'm going to use B for black, P for polo. Oh, that was not an R. Quickly erase that. Okay, so now we have to look at the pants because we just took care of the shirts. You write a P. Okay, so we're gonna start from right here from this branch again because as you guys probably noticed, trees have branches within branches. So there's branches that sprout out of the branch. So red polo has how many branches based off the options from pants? So how many combinations can the red polo have? It could combine with Levi's. it could combine with Wrangler, it could combine with Lee. So in total, you have 3 branches that sprout out from the red polo to make a combination with the Lee, to make a combination with the Wrangler, to make a combination with the Levi's. Very similar to the red polo, we have to look at the black polo. The black polo branches out too, and it could branch out to combine with, let me go ahead and back, with the Levi's, with a Wrangler, and with a Lee jean. So just like a tree, and let me actually draw one out for you. You have the big stem, and then you have the branches. And in the very top, those are the combinations. Those are the combinations that we'll be counting. So you basically just need to count the very last branches of the tree diagram. So let's go ahead and count them. We have 1 combination, 2 combinations, 3 combinations, 4 combinations, 5 combinations, 6 combinations. So going back to the question, what was it asking you to find? Go ahead and reread it if you need to. I hope you were able to identify that it was asking you how many combination choices Jose had. And in total, you have 1, 2, 3, 4, 5, 6. You have 6 in total. And I'll kind of explain it a little bit more in detail right now. So for this one, you had Levi's with the red polo. So you had a shirt, red polo, with some Levi jeans. Let me draw out the jeans. So that's why we counted it as 1 combination. We also looked at the Wrangler jeans. Let me use purple for this one so you could distinguish it. And that's why we counted this one as the 2nd combination, because it was combined with the red polo. You could definitely do your own type of tree diagram where you could modify this. I'm just showing you a very simple one because I'll be honest, it could get very messy if I write a little bit more. You could write it this way, which I'll show you right now. Lee plus RP. That just tells you that's 1 combination. You have Levi's and the red polo. You could do that to all of them, but it's not required. I'm just showing you another way you could probably do it. Anyways, that kind of summarizes this problem, and that's essentially it. You're just making a tree diagram based off a table. And yeah, you could definitely find probability of picking one of these combinations, but that was the extra step that we probably won't take this part of the unit because we are limited in time. So for example, I could say, what is the probability of getting a red polo plus a Levi jean? And since we can only observe that we only have one red polo, that have been 1 out of 6. Anyways, that just kind of summarizes a little bit of what we talked about. I hope you guys enjoy your. Definitely contact me if you have more questions. Goodbye.